Did you identify all statistical method unambiguously? Explanation of unusual or complex statistical method are done, and if statistical methods are described adequately, and were any of them clearly inappropriate? So they are asking, and do you know what is a proper statistical test to use and why that is important? So this graph shows scatter plots, and y-axis is NIH research funding, and then each data point is a disease. Okay, so you know for AIDS and how much NIH spent for that particular year. This is old data, by the way. And then x-axis is the disability-adjusted life years and loss due to illness. So if you show, you can tell the association, you can say NIH is using them effectively to save lives. Okay? So typical analysis you might do is the Pearson's correlation coefficients and p-value 0.5. And not statistically significant, but if you use the Spearman's correlation coefficient, p-value becomes less than 0.0001. So the user of a statistical test and really impact on the p-value. So in this case, and we need to know which p-value to pick, not the smaller p-value. And so the appropriateness of the statistical test is depending on the data, form of data. Okay. All right, so that form of data is linking to assumptions. So we need to know what assumptions are required for each statistical test, and then we need to show, check the assumptions so that statistical test we use is valid. Okay, and all right. So let's talk about assumptions. One of the most important assumptions for parametric test is the normality, and the parametric test is a t-test, regression, ANOVA, and pair t-test. They are all parametric tests. So in order to validate use of those parametric tests, we need to check normality in the data. So this is the data normally distributed, and then this is the data skewed. So in order for you to know t-test is valid, and you need to check distribution of your outcome variable within each group, and then see those are normally distributed. Okay? And otherwise, if you have a skewed data, you want to use non-parametric method. Non-parametric means distribution-free method. So using Spearman rank correlation is a non-parametric, so you don't have to worry about shape of data. So in this case, then you know both funding and the life-adjusted years are skewed, right? It doesn't look like normally distributed. Therefore, we know non-parametric test is more valid. So we can use this p-value. That's good. All right. And many people actually ask then, should I be using a t-test or should I be using Wilcoxon test? Wilcoxon test is a non-parametric test, and which does not require distribution. So it's great. We don't have to worry about distribution. We don't even have to check distribution if you use non-parametric test. And although I do worry about losing power, do I lose power by using a non-parametric test? Okay. So here I performed a little bit of little simulation analysis, and I wanted to feel how much of loss of power is happening, and by comparing student t-test and Wilcoxon test, and then also student test, but transforming outcome variable. So one strategy to deal with distribution is if you can log transform data and then make it to normal distribution, and then you can still use t-test. Okay, so here I'm actually I show you all three, and I'm comparing three different tests. Red line is a t-test, and with the log transformation. So data like this, after you log transform, become normally distributed. Okay? And then blue line is a Wilcoxon test, which is a distribution-free non-parametric test. And then green line is, so red, I think I mislabeled it. Green is a log transform t-test, okay? And then red is no log transform. So red is a regular t-test. Okay? And then red is a regular t-test in here. Okay. So let's see how much loss of power is happening. So when you have a completely normally distributed data, okay, And using Wilcoxon test is actually not so bad as using a t-test. Let me change this. Okay. T-test. Okay. All right. But since here the data are normally distributed, so if you log transform this and then you make a data skewed, so using a t-test with log transformation, and you actually hampering power. Okay. So y-axis is a power. What is a power? Well, power is the ability to detect the difference. So if the drug is effective and 100 people conduct your study, and then you can tell 80% power means 80% of people detect the signal. If the power is 5%, what does it mean? Only 5% of people detect the signal, even the drug is effective, right? So you do want to increase power. And then let's look at the skewed data. And skewed data, since transformation is useful, so it looks like a t-test with log transformation have more power. Okay? But Wilcoxon test is not that bad. But let's look at the t-test without the transformation. So you grab this data and then don't look at the distribution, apply student t-test, and then your power is decreased dramatically. Okay. And then last one is a very skewed data. So this data is actually the similar to the Augustus score and looking at the coronary calcifications. And Augustus score has a huge cluster of 0, but then some patients have a large value. So when you have a very, very skewed data, and a t-test absolutely have no power. Okay. And then, so in this case, a Wilcoxon test or t-test with log transformation, actually you gain power. Okay. So comparing a three method, and what do you choose? So as a statistician, and we, based on this, and we choose non-parametric test. Because using non-parametric tests, we don't lose much of power even when the data are perfectly normally distributed. And then power gain is tremendous, especially when the data are skewed. Okay. And the log transformation is good, although it doesn't work if the data are already normally distributed, or you need to know whether you should do log, or you should do square transformation, or you should do cubic root, or you should do, there are many types of transformation. So, and too many methods you have, and you might start fishing. So it's much easier for us. We just grab non-parametric test and then analyze data that way. Okay, and I have 2 more minutes. I mean, these are the slides, and I wanted you feel what are the variables you are dealing with. But anyway, these are right here. These are biomarker, and IL-2, IL-4, IL-10, IL-5, IL-18, TNF alpha. So most of the biomarker data are skewed. Right? So as many other data in biologies are skewed. So it's rare to see normally distributed data. Okay, so be careful to use a parametric model.